Hey there, in this video we are going to look at adding and subtracting rational expressions that have monomial denominators. We're going to use the technique of making a common denominator between rational expressions and using that to do the addition or subtraction.
Now, looking at adding and subtracting rational expressions, we're going to think and compare this to adding and subtracting rational numbers or fractions. Let's say if you have 2/3 plus 1/4, you're going to be able to put those together only if you have a common denominator on the bottom. So if they don't already have a common denominator, you're going to rewrite each expression with a common denominator. And what you're going to need to do is then decide, what do I need to multiply the top and the bottom here in order to make that? In that case, you need to multiply by 4 so that you have 8/12. In other words, 2/3, you're just rewriting it as 8/12. You're not changing what it is. 1/4, you're going to multiply by 3 to get 3/12. Once you have a common denominator, you can add the numerators and get 11/12. Right? The bottom tells you how big the pieces are, so you don't add 12 plus 12 here. The top tells you how many of each of those pieces you have. So then when we move on to working with rational expressions, it's going to involve the same thing. Rewriting expressions with a common denominator and then adding or subtracting the numerators. All right, so let's look at the first few here. This one actually already has a common denominator all the way across there. Denominator is 5x on all of them. So we can just write it as a single fraction with one denominator like this. And you have 11 plus 2 minus 3, or in other words, you have 10 over 5x. 10 over 5x is equivalent to those three fractions, added and subtracted. Now this actually you can reduce even more, because 10 and 5, you can divide the top and the bottom by 5 to get 2 over x. All of these things are equivalent to that expression we started with. This is the simplest version of that though. All right, let's look at the second one. Now we have different denominators here. We can make them the same if we think about what the common denominator could be. If we have 3x and 4x, the common denominator we could make is 12x, because we could multiply this by 4 over 4. Multiplying by 4 over 4 is like multiplying by 1. This is 1. If you multiply something by 1, you're not changing it. So you're not changing this expression when you multiply by 4 over 4. On the top, we're going to have 4x plus 20. Realize you have to think that there's brackets here around that. You're multiplying the entire expression by 4. So not 4x plus 5, 4x plus 20. The second thing here, we're multiplying by 3 over 3. And on the bottom we have our 12x. On the top here we're going to have 9x plus 6. Subtraction in between those two fractions. I'm going to write them as a single fraction before I try to put my final answer here. I have 4x plus 20 minus 9x, and I'm actually going to write this as minus 6, because it's important to realize that this is minus this entire expression. So it's minus 9, that 9x is positive, and minus positive 6. These are both positive here. Since you're subtracting them, they're both negative when you write them in your expression here. So what we have is minus 5x when we combine this and this, and we have plus 20 minus 6, so we actually have 14 plus 14 over 12x. Looking at this, there's no way to simplify that anymore. There's no common factor on the top and the bottom or anything, so that's our final answer. Let's look at two more. This one here, you have 6x squared and 9x as the denominator, so they're obviously not the same. We can make them the same by thinking about the lowest common denominator we can make there is 18x squared, because we need at least x squared for this one, and we need a coefficient that we can divide both by 9 and 6, and 18 is the lowest one. So if we make it into 18x squared, that'll work. That means we need to multiply this one by 2x over 2x, and we need to multiply this one by 3 over 3. So we're going to have 9 and we're going to have 2x over here. If we add that together, we have just 9 plus 2x over 18x squared. Or if you prefer, instead of 9 plus 2x, if you like it in the other order, you can write it instead as 2x plus 9. It's entirely up to you. But that's the simplest version of that expression that we started with. There's no way to reduce that at all. It looks like you have 9 and 18 here. Maybe you start to think that you could start crossing some things out, but remember, you can't cross off part of a binomial with anything on the bottom. Let's look at this last one here. Our lowest common denominator that we can use here is 2x squared, because we need an x squared and we need at least a 2. So that means we have to multiply this one by 2 over 2 and multiply this one by x over x. So we are going to get 4x squared plus 10, and we are going to get x squared minus 2x. Now, just like the one above, I'm going to write it as a single fraction here with a single denominator. 4x squared plus 10 minus x squared plus, because we have minus a negative term there, 2x. This is as though there's brackets around it, especially important when you're subtracting like that. All right? So if we simplify that, we have 4x squared minus x squared means we're going to have 3x squared. And we have a plus 2x. And we have a plus 10. And then we have 2x squared. Now there's not going to be anything that you can do with that, because there's no common factor in here that we can get rid of with anything on the bottom. You might again think, oh boy, I should be able to cross this out with this, but again, you cannot cross out part of a multi-term thing with something else. It has to be the entire thing. So this is as simple as it gets here for this. All right? So that's a start with adding and subtracting rational expressions. For this part, we've looked at only where there's single term denominators. In part 2 of this, we're going to look at multi-term denominators.